Hi everyone, welcome back. In this lesson we're going to be looking at where we are passing structures and instantiated structures into our function blocks. Very similar to a previous lesson that we've seen, however this is in a real project scenario. So if I go to my task configurator here and have a look at the order of execution on our main task, we've seen that we've already been through the input mapping. So we're now coming on to the next area, which is our inlet system. So if I open this, it takes me to the POU that it's calling. The first thing to notice is this stuff at the top here before we get to our managers. The stuff at the top here is all to do with actual control. So interlock control or logic control of our assets. So we're setting conditions such as this top rung here is setting wash required to wash our strainer, and this one here is checking if the wash has been complete. This sort of stuff I always keep at the top of a project, and I keep the managers at the bottom because you're much more likely to want to have a look at your control logic than you are wanting to sort of dig down through your standardized function blocks that handle your structured data. And with that being said, we're not really going to go through the logic in this project because, like I said in the introduction, this project is used for a multitude of things, not just this lesson. So we're just going to go through the structure stuff, but feel free to run this project in simulation mode and have a look at how it all works and how all the actual logic fits together if you want to, and ask questions. I will answer the questions if they're unrelated to the structured course about this particular project. That's fine. So let's come down to where our function blocks are. Now, I said in the previous lesson about calling them managers because they actually manage our structures. It's a terminology that I've sort of used for quite a long time. You can call them whatever you want. They are just function blocks. But in my projects, I call them managers to differentiate them from something that manages structured data and something that sort of handles interlocks or is just a supporting method to something else. So coming down to this switch manager here, I have a few configuration options at the beginning. So my preset for my debounce timer, obviously that could be tied to a variable if I need it to. But in the case of switches, 1.5 seconds is usually enough for a basic switch. And then I have my failsafe. So this is pretty much just inverting the signal that's come in from our input mapping layer. And then I have my alarm index for alarm management, which we will see as we come on later on in this project. And then my actual structured data, so SW001. If we go to our typed variable list and switches, you will find that data there. So SW001 data, and that's passed on reference through our in-out interface. And then I'm also passing my alarm data, and the alarm stuff will make a little bit more sense when we come to cover that topic in this project. But the key thing to realize is the alarm data is also being passed via in-out, and actually this alarm data is quite large. But the key thing to note is that we are passing our alarm data through a in-out interface as well, so by reference as well, and also the control management. So this is the ARM, alarm reset and management of the alarms. Any data that's required for that is also passed via reference, and you'll see these on the front of every single manager through the system. So every single manager has access to the alarm system via reference. Now remember that via reference means that it's a pointer essentially to the global data. There's no copying of information that happens, and therefore it is much quicker than passing that information on an input and then an output interface to update that information. So as we come down through this this inlet system here, we've got our two switches, and then we've got our quarter turn valve manager, which again, this is exactly the same sort of setup. However, because it's a device that has outputs and some control around it, we have our control elements first rather than our options. So my auto control enable is first, and this actually holds the control requirements. This naming convention here, QTV001 LT001 enable, just simply means that this asset QTV001 must be enabled from LT001. So LT001 is a tank or a level, and it will be handling this this interlock here to say if you're above or below a particular level, depending on how it's configured. This would be on and would allow this quarter turn valve manager to action what it's supposed to do when auto control enabled is on. And you can have as many elements as required here. Yeah, depending on how some of these options are set up on the front, determines how this behaves inside. So again, we have another control option here for disabling. So disabling the valve from moving. So as the description says, true equals valve not available for auto control. So it doesn't matter what's happening on this auto control enable. If disable is on, the valve's not allowed to be available anymore. It will act as if this is off, irrespective of what's happening. I don't have that connected in this one. And then I have my alarm management again. I have a input for travel time, and I have my operation mode, which is a special option, which is why it's not really with the other ones. I keep it above the data because this one actually affects the way the block works. So if I hold over this, if 0 is passed to it, it's a normally closed valve. If 1 is passed to it, it's a normally open valve. And if a 2 is passed to it, then it's no normal state, which basically means it's not a spring return or spring open. If power was lost to it, for example, it would just stay where it is. So it needs to be driven open and closed. And then keeping in with the structure theme, I have my global data coming in on data and my alarm management. And again, that's the same sort of setup all the way through the system. So if I was to go to my watch system, I get the same thing again. I get my controls at the top. So these are my interlock managements at the top for driving, like we saw just a second ago, this QTV, LT1 enable signal is simply coming off this. So if my tank is higher than the enable level, then I get my enable signal on over here. Feel free to dive in these blocks and have a look at how they're set up. But then coming down here, I have my managers again. So my hack manager, this one actually has two sets of information that comes to it. It has its QM001 analog data, so DUT generic analog, but it also has some additional data, which is the additional SC200 data. So it actually manages two data sets, this block. And that's worth knowing and remembering that you can do that, because you could build some quite big systems that wrap around a lot of managers and bring maybe 10, 20, 30 data sets in from your global individual lists, global variable lists, and manage them all that way by reference. It won't take up any extra memory for doing that. It'll still be just as quick as having them out individually, but you just get a nice interface at the beginning that sets up an awful lot of stuff. And again, as we come down, more stuff with more alarms on the front and more data sets, the same 3 data sets we're seeing every single time, 3 data sets again. And finally, the level manager, which again, here are our 3 data sets that are passed via in-out. So hopefully that gives a sort of sense of the difference between logic control, which is all happening up here, and in our inlet system happening up here, and the management of structured data. Because if I was to go into this switch manager here, you'll see that this is the code that is actually passed in and out of my structure. So I bring my my structured data in on data, so I'm checking the IO switch status, doing my debounce, and then if I'm fail-safe or not, I work out whether or not an alarm condition should be true. If the alarm condition is true, I then have my global alarm manager, which we'll come on to a bit later, and I manage the alarm for this particular asset, and finally I store all of this output of these different statuses. So like the switch state after the debounce timer is stored in data, the alarm condition is stored in data status, a nested structure, and again the alarm active is stored in data status, and finally failsafe is stored in data failsafe mode, so I can at least inform another process somewhere that this particular asset is running in a failsafe mode. Useful for just displaying on SCADA or a diagnostics page or something. And really that's it. That's all this sort of manager is doing. It processes the information and packages it back up into its data set, ready for use elsewhere in the project. And once you've got that sort of standardized, it means that every single switch that has this data set here, which is our DUT switch, goes through this function block and behaves exactly the same way. You can't have any copy and paste errors because you're copying the complete function and structure. You can't forget to do something such as put the alarm management in because it's already in this function. You can't accidentally leave stuff out of vital information on the interface because you don't have access to that interface. It's all passed through the structure. So the worst thing you can do is forget to include it or forget to include the structure. Those things become apparent very, very quickly that they're missing. Because when you come to your commissioning, stuff simply doesn't work because it's not there. But as soon as you put it there, everything will work correctly. And it's getting into that mindset of setting this stuff up to help you later on, because there is an element of time needed to sort of get to this position where you have this stuff packed away in libraries and things like that. But yeah, it's definitely worth it, because if someone says to me, can we add another switch in? I just drop another switch in and another set of switch information, and that's it. I'm then free to go off and focus on the important bit, which is the actual logic. What is that switch doing? Is it raising alarms, or is it actually controlling or shutting down a process, for example? And that's nice and easy to look at, because in our structured data, which is global and we can access from anywhere, I can go and access that information fairly easily, like I'm doing here. So switch 001, data status, alarm condition. If the alarm condition is active, then this goes true. I don't have to worry about where it's managed, what's managing it. I just need to worry about accessing that information and know that our standard switch manager here is performing its duty and updating that information correctly.